Hello everyone, welcome to the first episode of Discrete Math. The first topic that you should know in discrete math is set theory. What is a set? A set is an unordered group of distinct objects. There are no duplicates, and if two sets have the same elements, then they are equivalent, even if those elements appear in a different order. An easy way to visualize a set is a circle with objects inside. Again, notice there's no order. I can place any of these objects in any order and it will still be a valid set. We usually write out the contents of a set between two curly brackets like so. Here are some examples of valid sets. Sets can have numbers. They can have letters, they can have numbers and letters, and as mentioned before, they can be in any order. So the set you see on screen and the set I showed previously are the same set. You can also have empty sets. You can have sets of empty sets. And you can also have sets made up of other non-empty sets. If you want to talk about the size of a set, you use two straight lines surrounding the set name. So in this example, I have a set called A, and it contains the numbers 1 through 10. It has 10 items. So I write A between two vertical lines to signify I'm talking about the size of the set, which in this case is 10. The next thing you need to know about sets is the concept of union. The set A union B is any element that is in one or both sets. The symbol to represent union between two sets looks like a U. When talking about union, it's easy to look at sets as Venn diagrams. We have set A and B here, represented by two circles. And if you want to write out the set of A union B, you would do so like this. Remember, since sets cannot have duplicates, 6, 12, and 18 would only appear once. In short, union means something appears in either set. It could be in set A, it could be in set B, or it can be in the overlapping region between the two. Intersection means anything that is found in both sets. For example, in the set of A intersect B, 6, 12, and 18 would be there because they appear in both sets. An easy way to think about intersection is it appears in A and B. Intersection simply refers to that part of the Venn diagram where A and B overlap. If you want to count the size of the union between two sets, you would think that you would simply add the size of both the sets. But that's not true because we have to deal with these elements in the intersection. You see, because they are in both sets, if you simply added up the sizes, they would appear twice. So you subtract that size from the size of A and B. We know that set A is 10 items. We know that set B is 7 items. So we have 17. Then we subtract the size of set A and B, 3, to get rid of the extra copy of 6, 12, and 18. This means that the total size of A union B is 14. Let's look at a practice problem to better understand how set theory works. In a class of 40 students, 22 play hockey, 26 play basketball, and 14 play both. How many students play neither sport? So first, what are the sets here? Let's have set H represent those who play hockey, Set B represent those who play basketball. The next step is to list out what we know. What information do we have? The size of H is 22. The size of B is 26. The size of H intersect B is 14, because 14 students play both sports. And the total number of students is 40. And we also have this equation from before. We know that the union between two sets is the size of each of those sets added, and then you subtract the size of the intersection between those two sets. So we know that A union B is 22 plus 26 minus 14, which is equal to 36. So now we know 36 students out of the total 40 play one or both sports. And that must mean that 40 minus 36, 4 students do not play either sport. This is just one example of how sets are used in discrete math to solve problems. I hope you found this video informative, and as always, leave feedback in the comments.